Now we're going to determine the sample size needed for a given sampling error for a difference between means. Okay, so let's see. Find the appropriate values of N1 and N2, so the samples of N2 and N1 and N2, and it even says assume they are equal. Needed to estimate the difference of the means with each of the following. A sampling error equal to 3.3. Okay, so we talked about sampling error before, right? I call it SE for sampling error with a 95% confidence interval. Okay, with a 95% confidence, according to our C-score. I'm using the C-score. My C-score for 95% is 1.96. Now, from prior experience, it is known that the standard deviation of sample 1 is about 20, and the standard deviation of sample 2 is 17. Round up to the nearest integer. Okay, so let me give you guys our formula we're going to use for a sample. I'm going to look at my C-scored squared, and I'm going to multiply this. Let me open a big parenthesis here. I'm going to multiply this by the variance of sample 1 plus the variance of sample 2. Okay, so you notice how I'm not giving you the variance of each of the sample. I'm giving you the standard deviation of each sample. So obviously just square each of them. And I'm going to divide all of this by the standard error all square. Okay, so let me see, number-wise, looking at our numbers, how am I going to do this? What am I going to type on my calculator? So I'm going to go 1.96 squared times, and I'm going to open a parentheses in here. I'm going to have 20 squared plus 17 squared. Make sure you have that parentheses for the plus though. If you forget the plus, I mean the parentheses, if you just write, let me write it here at the side without parentheses, and then times 20 squared plus 17 squared. Your calculator will do the multiplication and then it will do the addition because it follows order operations. That's why I'm saying make sure you use the parentheses because you want the calculator to do addition before multiplication. Okay, and then if you want to put all of this inside parentheses, so you have the calculator doing it all together there, and I'm going to divide this by 3.3 square. Okay, make sure you type it on your calculator. I'm going to type it in on mine right now. According to my calculator, I get 243.05439885. Okay, I'm 243 and some more. 243 point something. Now, we talk about sample errors in previous units. Sample error, it cannot be, because it says rounded to the nearest integer, but it says round up to the nearest integer. So it cannot be, it has to be a whole number, but it cannot be less than 243.05. So if I go to the nearest whole number, my answer will be 243. However, 243 is less than 243.05. So I'm always going to go up to the next number. So I'm going to say this rounds up, always round it up. So my mean, my sample here, my sample should have 244. Again, I'm not going to the nearest whole number. I'm rounding up to the nearest whole number. So you round up. Always you go up because it cannot be less than 243.05. Okay, that was not bad. Let's take a look at question number 2. A sampling error equals to 9. Okay, so I have the sampling error. Let me use blue for this case. So let's see, have the sampling error with a 99% confidence interval. I remember from a Z-score table, my 99% confidence interval was 2.575. Now the range of each population is 60. Oh, I don't have the standard deviation. I have a range. That's not that bad. Our range, our standard deviation is going to be range divided by 4. Okay, so it's okay for me to have the same standard deviation for sample 1 and sample 2. Notice I didn't say the range of 1. I mean the variance or the standard deviation of 1. No, I just said the standard deviation is range divided by 4. So what am I going to type here? I'm going to go 2 point, because I had to type in my Z-score, right? I'm using the table, the formula in black from above. So I'm going to go 2.575 squared times 15 squared plus 15 squared. Because remember, my standard deviation is range divided by 4. So 60 divided by 4. And all of this divided by 9 squared. Okay, so let me type it on my calculator. Let me see, what do I get here? I get 36.8 and some more. So 36 point something. Okay, so that means this rounds up to 37. Remember, I'm not going to the nearest whole number. I'm rounding up. Okay. Now here, a 90% confidence interval. Oh, 90%. I remember my Z-score for 90%. Let me change this to red. Remember, my Z-score for 90% is 1.645. My 90% confidence interval of width 1.1. Huh, this is interesting. My standard error, my sampling error is not 1.1. What I'm saying is that I know that I have a small number. Remember, it was the mu minus the standard error, and then the big number is mu plus standard error. And then my mu is in the center, right? Now, what I'm saying is the difference between the big number and the small number is 1.1. But doesn't the variance has one standard error here and one standard error here? Because remember, I go mu plus, so there's one standard error. I go mu minus, so there's another standard error. So my standard error in this case is going to be 1.1 divided by 2. I'm looking at the width of the whole thing, so it's 1.1 divided by 2. Well, my standard error in this case will be 5.5. Let me see, 1.1 divided by 2, or 0.55. And I have my variance of sample 1 is about 5.5. My variance of sample 2, 7.3. Oh, cool. I have it how I need them. So what am I going to type here? I'm going to go 1.645 squared times 5.5 plus 7.3. I don't have to do squares on this one, right? Because look, They're already given us a square. Nice. And then at the bottom, I have to divide this by 0.55 squared. So let's see, what do I get here? 1.645 squared plus 5 times 5.5 plus 7.3 inside parentheses, and all this divided by 0.55 squared. My answer, I get 114 point something. That means this rounds up to 115. Good. Now, suppose you want to estimate the difference between two population means, correct to within 1.4. Okay, so that means 1.4 is my standard, my sample error, with a 95% confidence interval. I remember my C-score in this case was 1.96. If prior information suggests that the population variances are approximately equal to, and it says the variance of sample 1 is equal to the variance of sample 2 is equal to 16. Nice, I know both variances. And you want to select independent random samples of equal size from the population. How large should the sample sizes N1 and N2 be? Round up to the nearest integer. Okay, again, I'm going to use the formula I gave you guys on the very top. So I'm going to go 1.96 squared. Mr. Leonzo, so why do you put the square inside the parentheses, not outside? It doesn't really matter. You're basically squaring 1.96 times. I'm going to do times, and open the parentheses, because here I'm going to go 16 plus 16. Make sure the parentheses are there. You want the calculator to do the addition first. I don't have to do square this case because they were given squares already. And then divide this by 1.4 square. Okay, let me type that in here. Let me see what I get. This gives me 62 point something. So my answer will be 63. Like I said, I don't round to the nearest whole number. I strictly round up.